Okay, today's lesson might be a tad bit longer than normal, but it was either two really short lessons or one just a little bit longer. So get your pencil ready, and I need your calculator out too because you're going to follow along with me, and let's work through section 7.8, curve fitting with exponential and logarithmic models. We're going to model data by using exponential and logarithmic functions. We're going to use exponential and logarithmic models to analyze and predict. And our new vocabulary are exponential regression and logarithmic regression, and that's going to be all in our calculator. First, let's learn how to analyze data to figure out if it's exponential or not. If you look at this data here, it shows that to get from one point to another, you're multiplying everything by 3. So that's how we get the 3 to the x. So 2/3 times 3 times 3 times 3 times 3. It's an exponential function. But let's figure out how to do this on our own. Go back one, and it shows us that 54 over 18, 18 over 6, 6 over 2, 2 over 2/3. Those are all equivalent to 3. Notice the ratio of each y value, and the previous one is constant. So each value is 3 times the one before that, so the ratio of function values is constant for equally spaced x values. This data can be fit by an exponential function of that form. Remember, for linear functions, the first degree, first differences are constant. For quadratic, the second differences, and so on. That's what we've just worked on. We're going to determine these. So I'm going to work from right to left, which is backwards from how I normally work, but it's no big deal. We're going to do 12 over 8, 8 over 5, 5 over 3, and 3 over 2. Okay, we sort of have to look for equivalent fractions. This one simplifies to 6/4 and 3/2. That doesn't simplify, and I have 3/2. So no, this is not exponential. Let's try the next one. 81 over 54, 54 over 36, 36 over 24, and 24 over 16. Let's simplify these. Let's see, if I divide by 2, I get 12 over 8. Divide by 4, I get 3 over 2. See if I can do this one. 12, yep, if I divide the top and bottom by 12, I get 3 over 2. Divide the top and the bottom by 18, and I get 3 over 2. And divide the top and the bottom again, I get 3 over 2. So, yes, it's exponential, and the constant ratio is 3/2. That's the constant ratio. Okay, you try these. Push pause. Okay, if you look at the first one, notice there was a little typo that I just wrote in there. That would be 2.6 repeating. So if you put in the 2.6 repeating, you do get a ratio of 1/5. So this one is yes, and your ratio is 3/2 or 1.5. Work on the next one. And that second one is not an exponential function. Let's move on. Okay, in chapters 2 and 5, we used graphing calculator to perform linear regressions and quadratic regressions. We also did it in chapter 7, or 6. 6. We're in chapter 7 right now. You can also use an exponential model, which is an exponential function that represents a real data set. Once you know that the data are exponential, you can use exponential regression on your calculator to find a function that fits. This method of using data to find an exponential model is called an exponential regression. The calculator fits the exponential functions to a, b to the x, so translations cannot be modeled. Did you hear that? We are not modeling translations. Yay! But it's the StatCalc, and you can find that in StatCalc. Remember, if you don't see r squared and r when you calculate the regression, you do second catalog and arrow down to select diagnostic on. Let's try one. Find an exponential model for the data. Use the model to predict when the tuition at UT Austin will be $6,000. So first we're going to enter the data into two lists in a graphing calculator. I'm going to hit Stat, Edit, clear my list 1 and list 2, and enter. This would be year 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. I really do expect you to follow along. I'm entering the tuition now, $31.28, $35.85, $37.76, $39.50, $41.88. Okay, so that's entered in. And now I'm going to hit StatCalc and arrow down to the Exp and hit enter. You may have to enter a few times. My R² value is right here. I have A and B, and there's my formula, A, B to the X. So an exponential model is 3,236 times 1.07 to the T, where f of x equals the tuition and T is the number of years after the 2000 year. Now this next page is really important, so please enter this into your calculator because I want you to follow along on the next page. It's something really cool that I just learned. Okay, graph the data in the function model to verify that it fits the data. Right here is a really cool way to put the equation into calculator, and it works for the really long equations we've done in the past too. I'm going to hit, so to enter the regression equation is y1 from the y equals screen. I'm going to hit y equals and clear that out. I'm going to press vars, which is right underneath the down arrow. Choose number 5, statistics, press enter. I'm going to move over to EQ, and the first option is REGEQ. And it plugs in your equation into y equals. Which is really cool. So for those really long equations we've done in the past, this is so cool, and it works. I've been using it in regular algebra for a few weeks now. All right, so we're done with that. Now we are going to graph our equation. I actually went to the table, and I looked for where y equals approximately 6,000. My x looks to be about 9. So that's 9 years after the beginning, and if you go back, the beginning was 1999 to 2000. So 9 years later, you are at 2008, 2009. So sorry guys, the tuition's already reached 6,000 since we're past 2009. But let's move on. Okay, you try this one. Use exponential regression to find a function that models this data. When will the number of bacteria reach 2,000? Go ahead and try it and use that vars thing again. Okay, that's what I have so far. I'm going to go ahead and hit y equals, clear what's there, vars, number 5, EQ, and it plugs it in. I'm going to go to my table and look for where the bacteria reached 2,000. I have y is about 2,000 when x is approximately, I don't know, 10.2, and that is in minutes. Okay, that's pretty quick. All right. Okay, many natural phenomena can be modeled by natural log functions. You can use a logarithmic regression to find a function. Most calculators that perform logarithmic regression use ln rather than log. All right, so we're going to find a natural log model for the data. According to the model, when will the global population exceed 9 billion? So our population in billions and our year. We're going to go ahead and plug that in. Hold on. Okay, what I did, I entered in the population in billions, just as you see it, but for the year, just like I've taught you. Whenever it's time and a year is a time, you always start at 0 and enter in past that. This would be 127, 160, 174, 187, 199. Okay, and go ahead and hit the StatCalc, and number 9 is LNREG. Okay, and this will calculate out. There is a typo here though, and I've triple checked it and double checked my answers against them. It's just 24.405, but everything else is correct. Now you're going to go ahead and go to y equals, clear it, and hit vars. Let me clear it, hit vars, number 5, statistics, and then EQ number 1, which is REGEQ, and that's going to go into your y equals. Then go to your second table and look for where where x equals 9, which is 9 billion. Y is approximately 258. But if you remember, that's the y is your years. The original y, where y equals 0, is 1800. So 258 years later, that is the year 2058, which is your final answer. Okay, why don't you go ahead and try one? Another typo here. That should be a 3. Use logarithm regression to find a function that models this data. When will the speed reach 8 meters per second? So I got my equation. Y equals A plus ln x. I put it into y equals and looked at my table and got y is approximately 8 meters per second at x equals approximately 16.7. Okay, that's all we have for today.